we present TriHuman, a real-time and controllable triplane representation for detailed human geometry and appearance synthesis. Given a skeletal pose and a virtual view, our goal is to achieve high-fidelity rendering in the respective pose and viewpoint in real time. Importantly, our method also targets at generating high-fidelity geometry with correspondence over time. Moreover, our method should generalize novel poses and allows to render of photorealistic images and generate detailed geometry given unseen poses as input. Neural Actor and HD Humans both support synthesizing high-quality human rendering. However, their generated geometry is usually of lower quality and lacks high-fidelity details. More importantly, the runtime for both methods is rather slow and may take seconds to render an image or generate underlying geometry. Regarding the support for real-time inference, real-time deep dynamic characters allow synthesizing of motion-dependent images and geometry in real time. However, the generated images and shapes are usually of lower quality. To this end, we propose TriHuman, which is the first method that recovers a highly detailed geometry that is even in correspondence over time, and synthesizes photorealistic images in real time. Given skeleton motion and virtual camera as input, TriHuman can generate photoreal images and consistent geometry both in real time. Here, we show some results for various subjects performing novel poses. Note that we can handle various types of apparel, including loose skirts. Given novel skeletal poses as input, our method generates clothed human geometry with photorealistic surface details presented with topology-consistent meshes, which facilitates further applications like consistent texture editing and simulation. Here, we show more results rendered from novel viewpoints. Note that our method produces view-consistent and high-fidelity renderings. Here, we show a longer continuous synthesis result where the subject is performing a faster and more challenging motion. Next, we compare our method to previous work in terms of rendering quality. Note that our method achieves significantly better results than previous real-time methods. Moreover, we show comparable or even better results than offline approaches. Here, we compare the real-time methods on a more challenging loose clothing type. Note our method achieves better quality and consistent rendering. In terms of geometry quality, our method outperforms all prior works in terms of quality and high-frequency detail recovery. TriHuman can be adopted for consistent texture editing. For example, given short video clips generated with TriHuman, and flower images as texture. The texture image can be seamlessly inserted into the clothed human rendering. Notably, thanks to the consistent geometry generated by TriHuman, the inserted texture images follow the deformations of the clothing and preserve the occlusion resulting from variant poses. To unleash the full potential of TriHuman, we propose TriHuman Viewer, a real-time interactive system for visualizing and editing high-quality clothed human with various motions. Users may browse the clothed human rendering and geometry with training or testing motions. The rendering and geometry are computed in real time on the cluster server and streamed to the TriHuman Viewer frontend. Users may also switch to free viewpoint rendering mode to inspect the skeletal poses and the character's imagery with a camera orbits around the character. In DOF editing mode, users may customize novel motions through modifying skeleton DOFs. The DOF editing will induce dynamic effects such as dynamic shadows and folding wrinkles. Thank you for watching.